I, um, where am I? Okay. So yesterday it really bothered me that I couldn't figure out three of the questions. So I spent some time after the stream just going through it. Um, and then I tried walking my husband through it because maybe he understood. He didn't really get it either. But by walking him through it so many times, I think I might have figured it out. So number three, you can see all the little calculations I did. So number three, question three was find a fraction which is halfway between 3.3 over 5 and 4 over 5. Now what I did is I know that 3.5 is halfway between 3 and 4, right? But you can't have a decimal over top. So I did 3.5 divided by 5, which is 7 over 2 divided by 5, which is 7 over 2 times 1 over 5, which is 7 over 10, which is the answer. And there was another way of doing it, which is a bit simpler, which is 3 over 5 and 4 over 5. And then if I tried to make the next biggest denominator, which is times 2 times 2 times 2 times 2 is 6 over 5 and 8. Oh, sorry, 6 over 10 and 8 over 10. And obviously the number in between 6 and 8 is 7 over 10. So that's one way of doing it. There's two different ways of doing it. And then I actually tried it with different numbers. So I did 6 over 11 and 7 over 11, and it still worked. So then question 5, which was last Friday, Tony worked 7.5 hours. Express this time as a fraction of the day. So it would be, this is question 5, 7.5 over 24, right? So it would be 1415 over 2 divided by 24 over 1, which is 15 over 2 times 1 over 24, which is 15 over 48, which is divided by 3 is 5 over 16, which is the answer. Then number 9 was the most confusing. No, 8 and 9 was confusing to me. Because for number 8, an angle is 2/3 of a degree. Express this in degrees. So what I did was x over 360, because we're trying to figure out what the angle is, what the fraction of that is, because we know that it's 2/3. So what I did was I times this 360, then times 360 over 1, right? Because that makes sense, right? So which is 360 times 2, which is 720, divided by 3 is 240, which is the answer. But the thing is, I didn't really use the formulas that it told me to use. And then 9, which is a petrol gas, is 7/12 full. It contains 505 gallons and 5.25 gallons. How many gallons does it hold when it's full? And that one I did so 5.25 divided by 7/12, which is 21 over 4 times 12 over 7 which is 252 divided by 28, which is 9, which is the answer. So that's what I did. So I figured them out. So good for me. All right. So now we can move on to chapter 4. Which is two-dimensional shapes. So in this chapter, I will learn different types of triangles and polygons, how to use the angle sum of triangles and polygons, how to construct triangles, about the symmetries of triangles and polygons, and about tessellations. I hope I don't need a protractor again, because I do not have one. Maybe I need to go to the dollar store and get one. All right, introduction. Two-dimensional shapes are flat shapes, such as squares and circles. They are also called plane shapes. The geometry which deals with them is called plane geometry. Thales of Miletus, a Greek, laid the foundations of plane geometry in the 6th century BC. About 200 years later, Euclid's Elements contained a complete, rigorous treatment of it. 4.2 Triangles. The simplest two-dimensional shape is the triangle, a three-sided shape with three angles. As a triangle made of rods cannot be deformed, it is widely used in buildings and other structures. Draw a triangle on a paper and label it angles A, B, and C. See figure 4.2. Tear off the corners and fit angles A, B, and C together, as in figure 4.3. They fit along a straight line. From chapter 2, the three angles at the straight line add up to 180. So A plus B plus C equals 180. This suggests that the angle sum of a triangle is 180. Okay. However, this demonstration only works for the triangle that you drew. It does not show that the sum of the angle in a triangle is 180 for any triangle. To do that, you need a proof. In figure 4.4, the side AB of triangle ABC has been extended, and at B, a line has been drawn parallel to AC. Angles F, G, and H lie along a straight line. So, F plus G plus H equals 180. As angles G and E are alternate, G equals E. As angles H and D are corresponding, H equals D. So F plus E plus D equals 180. Therefore, the angle sum of a triangle is 180. The triangle in figure 4.5 is acute angled, as its angles are all less than 90 degrees. An obtuse triangle, figure 4.6, has an obtuse angle, and a right-angled triangle has a right angle. So there they are. There are three other types of triangles. An equilateral triangle has three equal sides and angles. As the angle sum is 180, each angle is 180 divided by 3, so 60 degrees. In figure 4.8, the marked side shows that they are equal. I guess those signs mean they're equal. An equilateral triangle has three lines of symmetry, shown dotted in figure 4.9. If the triangle is folded along one of its lines of symmetry, one half of the triangle will fit exactly on top of the other. An alternate name for a line of symmetry is a mirror line, as one half of the triangle is mirror image, or reflection of the other half. An equilateral triangle has rotational symmetry of order 3. That is, the number of ways a triangle of tracing of the shape will fit on top of itself without turning it over. In figure 4.10, the point of the triangle about which the tracing paper turns is called the center of rotational symmetry. A triangle which has two equal sides is called an isosceles triangle. In an isosceles triangle, the angles opposite the equal sides are also equal. The reverse is also true. If two angles of a triangle are equal, then the sides opposite them are also equal. So the triangle is isosceles. Isosceles is a Greek word meaning literally equal legs. An isosceles triangle generally has one line of symmetry. Figure 4.2. Okay. And rotational symmetry of order 1. That is, a tracing of the triangle will fit on top of itself in only one way. In the special case when the isosceles triangle is equilateral, it also has three lines of symmetry. In figure 4.13, find the sizes of the angles marked A and B. The triangle is an isosceles. So 67, A has to be 67, and then 67 plus 67 or 180 minus 67 times 2. So the triangles, so the angles opposite the equal sides are equal, yes. And so A equals 67, did that. As the angle sum of the triangles 180, B equals 180 minus 2 times 67, which is 46. Triangles with no equal sides and no equal angles are scaling triangles. They have no lines of symmetry and rotational symmetry of an order of 1. Exercise 4.1. In questions 1 through 9, find the size of each of the angles marked with letters. In some questions, you will need to use facts about the angles from chapter 2. The triangles are not drawn to scale. Okay. So, should I write down equilateral, isosceles, scaling? Anyway, so exercise 4.1. So this would be A equals 180 minus 48 minus 51, which is what? Just gonna get the old calculator out. So 180 minus 48 minus 51. That's not right. 180 minus 48 minus 51. 81. So A equals 81. 2. C and B. Those two are the same. So what does that mean? We can do this. We can do this. So is that 73 then? I feel like that can't be 73. If these are equal. Okay, so B has to be 73. So B equals 73 and C equals 180 minus 73 times 2, which is 73 times 2, 146 minus 180 is 34. So C equals 34. 3. So it would be 54 so 180, so D would equal 180 minus 54 plus D2, right? Yes. No, I can do this. So it's 54 plus D2 equals 180. Right. So if I do minus 54, this is 3, minus 54 So D2 equals, what's 180 minus 54, 126. So divided by 2 is D equals 126 divided by 2, 63. 4. E and F. So if they're all equal, so it's 180 divided by 3, 60. So it's E equals 60, and F equals 180 minus 60, which is 120. 5. There's 9 questions. 5. So G would be the same formula as this up here. So G equals 180 minus 54 divided by 2, 63. Six. That's 90. Am I doing that right? I better check. 4.1. Let's do 3. 63. Okay, it's right. G5 is 31. (180 minus 118, 62 divided by 2. Oh, just wrote it wrong, I guess. 31. So 6 would be what? 90 minus 90. Yes, obviously it was 90 divided by 2, 45. So H equals 45. 7. So 58. So I is 58. I equals 58. And then J equals, oh, we can't see it, sorry. J equals 180 minus 58 divided by 2. 180 minus 58 divided by 2, 61. 8. 132. So then this angle is 180 minus 132. So 180 minus 132 is 48. So this is 48. But we don't need to know what that one is. Right? Do we? So these ones would be equal because they are even. Yes. So it'd be 48, 180 minus 48 divided by 2, 66. So K equals 66. 9 is, these are F angles, so L is 68. And then M equals whatever, 44. 44 plus 68. And then 180 minus that, which is 68 again. In theory. Okay. 10. One of the angles of an isosceles triangle is 74. The other two angles are x and y. Find two possible pairs of value for x and y. So 10, there's a triangle. There's a triangle. And one of the angles is 74. Okay. The other two angles are x and y. Find two possible pairs of values for x and y. So x and y could be, I mean, anything that adds up to 180 with 74. But it's isosceles, so it has to be equal on both sides. So if 74 is the top angle, okay, so there's two possibilities here. There's two different kinds of triangles I can make, right? There's two isosceles triangles. And so if I put the 74 here and the x and y there, or I could put the 74 here and the x and y there. So if the 74 is here, the y would be 74, and the x would be 180 minus 74, right? 74 minus 74, which is 32. But if the 74 is this one, then the x and the y would be 180 minus 74 divided by 2. It's 53. 53 and 53. 11. One of the equal sides of an isosceles triangle is extended, and the angle between the extended side and the other equal side is 40 degrees. Find the angles in the triangle. Okay, so there's an isosceles triangle. One of the equal sides, so here's the equal sides. One of the equal sides is extended. Okay, and the other equal side is 40 degrees. Maybe they're talking about that as 40 degrees. Find the angles in the triangle. Okay, so then we need x, y, and z. So if this is 40 degrees, so it would be 180 minus 40, which is 140. So z would be 140. Y would be the same, would be 140. And so then x would be 40. Let's see if I'm right. Okay, so A equals 81, B is 73, and C is 34. D is 63. E equals 60. F equals 120. G is 31. H is 45. I is 58. J is 61. K is 66. 68 and 68. So 30, okay, X is 74 and Y is 32. Yes. Or X is 53 and Y is 53. Boom, boom. 140 and 20 and 20. I had 140, right? Maybe it means this way? Let's see. Let's see if I can do it their way. Because they wanted 140 and then 20 and 20. So I think it means the other way. I extended it the wrong way. $140 and 20 and 20. 140, 20, and 20. Okay, so let's try extending it this way. So there's the triangle, right? There's two equal sides, and then we extend one side. And then that is 40 degrees. So that would be 140. And then that would have to be 20 and 20 to add up to 180. Okay, so I extended it the wrong way. Okay, so chapter 4.3, constructing triangles. Constructing triangles. Given 3 suitable measurements, you can make an accurate drawing of a triangle with a ruler, a pair of compasses, and a protractor. If the corners or vertices of the triangle are labeled A, B, and C, as in figure 4.14, the length of the side joining A and B are denoted by AB. Example, in triangle ABC, AB equals 3 centimeters, AC equals 2.5 centimeters, and BC equals 2.7 centimeters. Make an accurate drawing of the triangle. Choose one of the sides, say A and B, as the base. Draw a line 3 centimeters long and label it sides A and B. Set your compass to a radius of 2.5 and with the point on A, draw an arc, part of the circle, with the point at the compass on the B. Draw a second arc on the radius 2.7. To cut the first arc at C, draw a line from A to C and a line from B to C to complete the triangle. Yes. You can construct a triangle if you are given the length of one side and the sizes of 2 angles. If necessary, you can, of course, work out the size of the third angle of the triangle. You can also construct a triangle if you are given the lengths of 2 sides and the size of the angle between the 2 given sides. If you are given 2 sides of an angle other than the included angle, you can sometimes construct 2 different triangles from the information. If you are given 3 angles whose sum is 180 and no sides, you can construct an infinite number of triangles from the information. Oh, I do not have any of those things. I do not have a protractor, a compass, or a ruler. I think I might have a ruler, but I do not have the other things. So I cannot do that. I wonder if there's like pictures in the back. I doubt it. Yeah, there's no. So I'm just going to skip ahead to 4.4. Quadrilaterals. A quadrilateral is a shape with 4 straight sides and 4 angles. You can investigate the sum of the angle of a quadrilateral in a way similar to one used for triangles. Draw a quadrilateral and label its angles A, B, C, and D. Tear off the corners and fit the angles together at a point. From chapter 2, the angles at a point add up to 360. This suggests that A plus B plus C plus D is 360 and that the angle sum of a quadrilateral is 360. To prove this, draw a diagonal of a quadrilateral, dividing it into 2 triangles. The angle sum of each triangle is 180, so the angle sum of the quadrilateral is a 360. A square is a quadrilateral with 4 equal sides and 4 right angles. A square has 4 lines of symmetry and rotational symmetry of an order of 4. A rectangle has 4 right angles, and its opposite sides are equal in length. A rectangle has 2 lines of symmetry and rotational symmetry of an order of 2. A parallelogram has opposite sides which are both parallel and equal in length. A parallelogram has no lines of symmetry and a rotational symmetry of an order of 2. A rhombus is a parallelogram with equal sides. It has 2 lines of symmetry and a rotational symmetry order of 2. A trapezium has 1 pair of parallel sides. It generally has no lines of symmetry and has a rotational symmetry order of 1. An isosceles trapezium, in which the non-parallel sides are equal in length, has 1 line of symmetry. A kite has 2 pairs of adjacent sides with equal lengths, with like 2 isosceles triangles with their bases joined. A kite has 1 line of symmetry and a rotational symmetry order of 1. In the figure, work out the size of the angles of marked X. Okay. 1. So it would be 360 minus 96 minus 47 minus 105. So X equals, let's get the old calculator out. 360 minus 96 minus 47 minus 105 is 112. Write down the names of 2 quadrilaterals with rotational symmetry of an order of 2. Parallelogram and a rectangle. parallelogram and a rectangle. 3. Write down the names of 3 quadrilaterals whose diagonals cross at right angles. 3 quadrilaterals whose diagonals cross at right angles. What does that mean? Whose diagonals cross at right angles? I guess squares and rectangles? Squares, rectangles, and trapezium? Maybe? No. I mean, you could, I think. Okay, what's a rhombus? A rhombus? Figure 4.25. Okay. 4. A quadrilateral has m lines of symmetry. Write down all the possible values of m. A quadrilateral has m lines of symmetry. Write down all the possible values of m. 4 and 2 and 1, right? A quadrilateral has a rotational symmetry in order of n. Write down all possible values of n. Rotational, so that would be 4, 2, and 1 again. Six, construct an accurate drawing of quadrilaterals A, B, C, and D from information given below. All lengths are in centimeters. Oh no. I don't have anything to do that with, so I'm just going to check the answers to the ones that I could do. So 4.3, 126. Oh, 112, yes. Parallelogram. A rectangle, yeah. Square, rhombus, kite. Square, rhombus, trapezium. Oh, kite. 4, 2, 1, 0. Oh, 0. And 1, 2, 4. Okay. I think I'm going to call it a day here. Because polygons are next. Okay, yeah, I'm going to call it. Thank you for joining me. Have a good afternoon.